So this is going to be a mini lesson on Chapter 1 recap. One of the things that we studied in Chapter 1 were how to find intercepts. The first kind of intercept I'm going to find is the x-intercept. You do that by letting y equal 0. In this instance, I notice that the equation here is a fraction, so I'm going to put the 0 over a 1, and I'm going to solve this by cross-multiplying. Okay, so 0 times all that stuff is 0. 1 times that whole numerator is just the numerator. Okay. I noticed that the fourth power here, this quartic, could have at most 4 answers. And I'm going to go ahead and solve this by factoring. Maybe I'll make an MA table. MA table 4 times negative 27 is negative 108. And the adding number is 3. So a common mistake I've been seeing is people will spend some time here and find the correct numbers. So the numbers are negative 9 times 12. Okay, you don't just throw those in the answer. These numbers split the middle. Okay, so what we have now is 0 equals 4x to the 4th, and the middles are splitting. Not 3x squared, but negative 9 and positive 12. And since the middles are squared, it's going to be negative 9x squared plus 12x squared minus 27. Okay, then you go ahead and do some factor by grouping. I will take out, I guess, just x squared. And that leaves us with 4x squared minus 9. And then here I will take out positive 3, leaving us with 4x squared minus 9. Perfect. I notice it's working. So we have 3x. Difference of squares can factor further. The x squared plus 3 cannot. So 2x minus 3 and 2x plus 3. Okay, so this is a great factoring review problem. So the x-intercepts are plus and minus 3 over 2 comma 0. I got just a little bit of space left, but that's okay because the y-intercept is always the easier one. To find a y-intercept, you put 0 in for x. So that's 0, that's negative 27. That's a 0 over 7. So the y-intercept is 0, comma, negative 27 over 7. Okay. All right, moving on to number 2. Solve algebraically. This is that example where we have some denominators and we would like to eliminate them. So the common denominator between 5, 3, and a 1 is 15. The first fraction here is going to get multiplied by 15, as well as the second one. Okay, and don't forget this term way over here is also going to get multiplied by 15. What you do to the left, you do to the right. Okay, now step 2, remember, was cancel. So we're not going to distribute a 15. We're trying to eliminate these denominators. So 5 cancels with 15 to make a 3. And 3 cancels with 15 to make a 5. And now let's start our distributing. 3 is going to get multiplied into this quantity here and make 6x minus 21. This is a minus 5. So I'm going to distribute a negative 5 into both of these right away. Okay, negative 20x. And a negative times a negative makes positive 25 equals negative 150. Let's go ahead and add our like terms. The x terms here are going to combine to make negative 14x. The numbers combine to make positive 4. And from here, it's just straight out solving. Single x, we're going to get one answer. Negative 14x equals negative 154. Divide both sides by negative 14. And x equals 11. Okay, so don't forget the steps there. I think they're on page 7 of your packet, so go look that up. Number 3, this is a calculator question. So we've got a cubic. Okay, so let's just refresh everyone's memory here. When you have a third power, this is a cubic. All right, let's go to y equals here and pause the video if you need to and type in the cubic into your graphing calculator. The point of this video is to play along and refresh, so don't just watch me, but actually go ahead and do this live, please. And then remember, the regular viewing screen is Zoom, and it's number 6 standard right there. So I'm going to pick standard, which is 10 by 10. And if you don't like what you see, you can zoom in, out, things like that. Okay, I think this is pretty good. Maybe I'll squeeze in just a little bit there. So let's change the X window to -5 by 5. I'm seeing a clear graph here. Not sure if it's going through the origin or not. So I am going to ask the calculator, are you going through the origin? No, what I'm going to do is do second calculate and pick number 1 value. So I'm going to ask about x equals 0. Does this graph pass through the origin? And the answer is no. It passes through the point 0, 1. So when I draw my graph here, it's a cubic. And the cubic is going up, up, up. It's going down, down, down. Looks like it's going down a little farther on that side. Okay, and this is clearly at 0, 1. Okay, so here's the graph. If you're not sure what's happening in your graphing calculator, you need to adjust the window and ask the calculator for values. Okay, so here's my graph. Is it symmetric to the x-axis? If you were to take your paper and fold it on the x-axis, does it match up? I do not believe it does because the little humpy down here does not match. So no, it is not symmetric to the x-axis. What if I fold along the y-axis? Does it match up? Okay, no, it does not. And the final question is origin. This could be a little tricky when you're looking at a calculator. I really like my graph here because this point is going to help me decide when I spin the graph upside down, is it still going through the point 0, 1? And the answer is no. Okay, so not all cubics are odd. This one, because it was shifted up slightly, is not symmetric to anything. No, no, no. Okay, the next thing we're going to practice is x-intercepts. So if you look at this graph, there are 3 places it does cross the x-axis. Okay, find the x-intercepts. So I'm going to go to second calculate 0. And I'm going to go for this left, this negative intercept first. I'm going to go left, left, left until you're clearly passed and hit enter. Right, right, right until you're clearly passed. Write down enter. Guess, I'm just going to click once and get in the middle there. And the x-intercept, I'm going to round to 2 places, is negative 1.31, 0. Okay, this said x-intercept. Remember, intercepts are points. Okay, we did use this technique sometimes when it said solve and there was a 0 there. If there was a 0 and there was no y value, then you wouldn't say a y. You would just say x equals. Okay, so there's some fine details there. Let's keep going to find the next intercept. I'm going to pick 0. That's to the left of it. And rounding to 0.14, 0. And the final intercept is left bound click, right bound click. The x-intercept is 1.84. 1.84, wait a minute. What is this calculator trying to tell me here? This is really weird, okay? But I'm glad it happened because some people freak out. E means scientific notation, and that's times 10 to the. So 1 times 10 to the negative 12th power. The calculator was trying to get really, really close, okay? And the closest it was able to get was 1, but I have to move the decimal 12 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is the answer that the calculator gave you. 0.00000. It was trying, And the best it could get is that it's trying to say 0. Okay, so you just say 0. All right, the next thing we're going to do here is local max and local min. So looking at this graph, the highest it reaches is infinity, but the local max is right here. That's a local max, and this is a local minimum. Okay, these are points, a local max and a local min. So we're going to write these as points as well. Okay, so to do this, we're going to go second calculate, and the first one I'll find is that maximum right there, so number 4. And again, 3 clicks. Let's go to the left of that maximum. Left, left, left. I'm clearly to the left of it. Right, right, right. Clearly to the right of it. And the maximum is at the point, 2 places of rounding, negative 0.69, comma 3.89. And I'll find the local minimum next. Second calculate. Minimum is number 3. That's to the left of the minimum. Now I'm going to go to the right of the minimum. Guess, just click somewhere in between. And the answer is 1.13, comma negative 5.14. Okay, so those are the local max and local min points. All right, now something different is happening here with letter D. Okay, this is a solving problem. I notice here that this equation has only x's. Okay, so we need to state our answer as x equals. Okay, what I'm going to do with my graphing calculator, though, is go to y equals. I'm going to type the left-hand side here. This equation is going to be y1. And then I'm going to type another equation right here, y2. And then my calculator is going to help me find where y1 equals the y2. So where's y2? Alpha y equals fraction. I love that button. 1/7 x minus 4. Okay, let's just check to make sure I can see what's going on. It looks like we have 3 intersection points. So I'm going to get 3 answers ready here. We're going to have x equals approximately. Okay, second calculate, and we're going to do intersect. And this goes a little faster. Is the first curve y1? Yes. Always hit enter. Is the second curve y2? Yes, just hit enter. Okay, guess is where it's going to get a little more interesting. I want to get closer to the first one. And x is equal to negative 1.55. Now remember, we don't state the y value because this problem did not have any y's. They want me to solve for x. My answers are x equals. Okay, the second one, intersect. Enter, enter. Let's just get close to the second intersection point. So he knows which one I'm trying to go for, 0.71. Okay, check your rounding. I'm going to put a little note here. Round nicely. Round nicely to 2 decimal places. So the third number is an 8, so 0.70 rounds up to 71. And the last intersection point, let's just make sure I tell the calculator, tell me the third answer, 1.51. Okay, a lot of calculator review right there. Points versus x equals. Okay, number 4 is a no calculator question. This one's going to be find the equation of a secant line. Okay, so a secant line is just a line that touches twice. Oh, the directions say slope intercepts, so that means y equals mx plus b. I'll have to make sure that that's how I do it. And then we've got this weird stuff here where it says 2, then g of 2. So the first thing I'm going to have to do is plug 2 into the g function. Negative 2 squared plus 5 times 2 is going to make a 6. So the first point I just calculated was 2 comma 6. Now I'm going to plug 7 in. G of 7 is negative 7 squared plus 5 times 7, and that's negative 14. So the second point that I just calculated was 7, negative 14. Okay, step 1, find 2 points. Step 2, calculate the average rate of change. When I say average rate of change, that's just a fancy way of saying find the slope between these points, even though the graph is not straight. Okay, so let's start with a y. I'll start with 6. 6 minus 14 is plus, and then 2 minus 7. So 20 over negative 5, so the slope is negative 4. Okay. I think that point slope form is a little easier to work with, so I'm going to do that. Y minus 6 equals m, which is negative 4, times x minus 2. Y equals, distribute, negative 4x plus 8 plus 6 is plus 14. Okay. I rearrange, distribute, because it said slope-intercept form. If it doesn't say on the test, you can give me either form you want. Okay. Well, what about the people that chose this point? They're going to get the same answer. I'm going to show you that the answer is the same, and it's kind of a nice way to check. Y plus 14 equals m times x minus 7. All right, watch this. Y equals negative 4x plus 28 minus 14 is plus 14. Oh, look at that. The answer checked out to be the same. Okay, make sure you know how to calculate slope and lines in both forms. The last thing that we studied was parallel perpendicular lines. Okay, so let's just write down some notes here. If lines are parallel, then they're going to have the same slope. If I say please write an equation of a parallel line, then you make the slope the same. Perpendicular means opposite, reciprocal slope. The slopes need to be opposites, plus and minus, and they need to be reciprocals. Okay, so here's how lines could look. They could be parallel. They could be perpendicular. Vuxhoys are even perpendicular too. Okay, or maybe they're neither. Maybe they're just two nice lines intersecting, not at a 90-degree angle. Okay, so it doesn't have to be parallel or perpendicular. The third option is neither. They're just two intersecting lines. In order to do this question nicely, we're going to have to rearrange everything, though. So the first thing I'm going to do here is move the 8 over, switch sides, switch signs, and then divide everything by 2. 4x minus 7. So the slope, the first slope, m1, is 4. Equation B is already in y equals mx plus b, so this doesn't need a lot of work at all. The second slope that I'm noticing here is 1/4. Equation C, this needs to get some work done on it. Negative y equals 4x minus 9. Divide everything by negative, or change. I divided them all by negative, and the third slope here is negative 4. Equation D is going to need a lot of work. I'm going to switch sides. I'm going to move the negative 5y to the left, and he becomes a positive. 20y is going to stay, or 20x stays on that side, but the negative becomes, and now it equals 4x plus 1. And the fourth slope I'm noticing is a 4. Okay, so are any of the lines parallel? Do any of these have the same slope? Yes. Okay, so A and D are parallel. They have to be exactly the same. Okay. Are any of the lines perpendicular? One's positive, one's negative. Here's a negative. These are all positive. The opposite reciprocal of negative 4 would be positive 1/4. So these two right here, B and C, are perpendicular. Okay, I hope that these 5 little questions here was enough to kind of review a lot of the things that we talked about. Be ready for a test tomorrow that has 2 pieces of paper. One paper has a calculator and one does not. And I tried to give you some little hints here as to what you should be able to do without your calculator. Okay, I can't wait to see you tomorrow. Bye.